So I will be going to talk what is there in the Hawkins paper of particle creation by black hole. So it starts with a simple observation that in Einstein's field equation, the right hand side is actually has some component because of matter field, and matter field is represented by some quantum fields. So and while the left hand side is purely represented by a classical object metric tensor. While there is some part of stress energy tensor which is quantum in nature, so there is inconsistency, and at that time at the writing of that paper people don't know any consistent way to get a averaged T alpha beta to put in this equation. So what he tells is basically that in his paper he is going to assume that the usual quantum fields equation where we use the Minkowski tensor is going to be replaced by the curved space-time tensor, and because of using this we get this process of particle creation at later times because of indeterminacy, because we can't split the quantum fields in positive frequency and negative frequency with respect to the time-like killing vector. So he justifies this problem of particle indeterminacy, or the number of particles measure different by different observer using a Riemann normal coordinates, which I don't understand the calculation. So what he essentially gets by using the Riemann normal coordinates is that there is some indeterminacy if an observer has a coordinates of length p, or he uses some parameters and he gets a relation of number of particle indeterminacy in terms of a function of f beta, which is, I think it's b square or something. So he tells that this indeterminacy is actually the negative energy density, is related to negative energy density. So as the black hole radiates, it can be viewed as this is a black hole, and as it radiates there's positive energy flowing, there's a positive energy flux flowing out of the event horizon, or it can be considered as a negative energy flux going inside the event horizon. That's why the area of black hole decreases, and the area of black hole decreases is in clash with the previous idea that the black hole's area can't decrease. So here the black hole area decreases because of this indeterminacy, which is also can be interpreted as the breakdown of weak energy condition. And he tells a little bit about justification of why particle creation by black hole is in harmony with the previous Bekenstein idea that black holes have an entropy. So now how does he do the calculation? So basically what I will be going to calculate is the particle created by a Schwarzschild black hole, and in Schwarzschild black hole he does this, and he will be going to take a spherically collapsing body. So he starts with, we know that the Penrose diagram of a collapsing body is something like this. Let me get it right. This is I plus, this is I minus, this is Cre minus, this is Cre plus, this is r equal to 0 singularity. And this part of this is the surface of the collapsing star. This is the surface of the collapsing star, and this part is inside the surface of collapsing star. So he starts with, he takes two observers, one at I minus and one at I plus, and he is going to do the calculation for the simplest field, a massless spin zero field. So there the field equation are simply now depending on the observer. So if an observer is here and we have a at both of these places, scree plus and scree minus, we have time like killing vectors. So time like killing, because of these different time like killing vectors, and when we take quantum fields, we do the separation of quantum field according to the positive frequency with respect to the time like killing vector of scree minus, scree plus. We'll be going to get two sets of fields. So he says for scree minus, phi can be written as some operator a f plus b, a dagger f complex conjugate. So because of the time like killing vector separation using time like killing vector, these operators a and a dagger can be interpreted as annihilation and creation operators. Now for the other part, just because just a second, scree minus, there is this mathematical issue and I don't understand why properly this fact, but to get a complete set of functions, we have to use not just the functions, not just the field equation, not just the quantum fields on scree minus, but also at the event horizon. Then only we will be going to get complete set of complete functions, so that any field can be written, anything can be written in terms of linear combination of those fields. So phi also can be written again as b p b dagger p complex conjugate plus this can be written as c q plus c dagger q complex conjugate. Now this b and b dagger, these functions p are the strictly outgoing function, that is they end up on scree plus and scree plus. So these b and b dagger can be interpreted as the creation and annihilation operator at scree plus, while because of there is no time like killing vectors on the event horizon, these C and C daggers can be interpreted as annihilation or creation operator, but they won't be going to cause any problem because we won't be going to need them for calculating particle created. So initially when the collapse starts, we are at this point, we are here. So we have the vacuum, something like we have a vacuum represented by this, and this vacuum has a property that it is going to get annihilated by A. But after the collapse has happened and at later times, we will going to measure the number of particles. For that we have to use B and B daggers because we are doing the experiment here. So there we will be going to use this is the expression, and one can do the calculation and B and because these are complete functions, these are two sets of complete functions, they can be written in terms of each other. So it gets written in terms of A and A dagger, and something you get the relation, you get some, you go because if we start at initial time, we know that this is going to be 0, but because this can be written in terms of A and A dagger, this won't be non-zero, while this will be 0. So at initial time we don't have any particle, but at later times we will going to have the particle. So now f, so the form of f is something if it's done in vault. So basically an vault gets a factor 1 by r. I will tell you, if f can be written in terms of 1 by 2 pi omega dash 1 by r, some function of omega, and yeah, he does two more things, because we are having a spherically symmetric collapse. So we will be going to separate the equation of motion in angular and spherical part by the spherical functions, spherical harmonics, and so this part remains aside, and this part we get some function of from this. Now this part is due to normalization condition. Basically f omega dash something goes like this. Basically this part, the constant before delta here has to be 1. So this comes because of this. While this function 1 by r, it can be derived and it's done in vault. And for the p omega, one gets the same relation, 1 by 2 root 2 pi omega 1 by r p omega r something ylm. Now these are two sets. This is a complete set of function. So p omega can essentially be written in terms of now our whole task now reduces to calculating b omega. Yeah, our whole task now reduces to calculating these alpha and beta. Now to do this, what he does is we know the function p omega here, and we know the function f omega here. I will draw a different diagram here. We know the function here. Just a sec. Yeah. We know the function here. These are f omega dash and these are p omega dash. P omega. And he already took the Fourier component, I guess. Yeah. Here he already took the Fourier component, Fourier transform with respect to retarded and advanced time, which are usually t plus r plus ln r by 2m something. They are simply the t plus r star, where r star is the radial part in the tortoise coordinate. So you get these things. Now I plus and I scree plus and scree minus. So what he does is we start at some point, then goes back and comes here. This is how the scattering of p omega will happen if we do time reverse scattering. Basically we reverse the time, and instead of the outgoing wave it will become incoming wave, then it will get scattered by the collapsing star and come out on ice cream minus. So what is so at the particular advanced time v naught, which can't escape to the scree plus, we get the event horizon. So this point, this ray is a part of null generator. Though I won't be going to detail of the how this null generator will be used in the calculation. The basic point is using these waves, using these rays, using these paths, we will eventually going to represent p omega in terms of f omega, some form of f omega. Now he does it by using analytical continuation of manifold, and though I don't get the part of it, but basic point is that after doing the calculation, p omega gets some form of something into exponential minus omega by kappa, where kappa is surface gravity, log v naught minus v by some constants. These constants won't play any role. And there is an issue here. The fact is that this we get this equation, and this equation is only valid for v very close to v naught, and v has to be less than v naught. For v greater than v naught, we won't be going to get any p omega. Now we took the it's just that we have to take a Fourier transform of this function and integrate it from minus infinity to infinity dv. But the problem here is that for this function is 0 for v greater than v naught, so we have to just integrate it up to v naught. The relation he gets by substituting so he gets what he gets there is actually valid only if this whole function is true for v close to minus infinity as well. But while we derive p omega, we found that v has to be close to v naught for this function to be valid. Now I don't get why it is there. Basically maybe because of some asymptotic expansion, but I am not quite sure. But after doing the calculation, you get some form of you get alpha omega dash to be of some form. There are some constants, and it's omega minus omega dash v naught minus I omega minus 1 plus I omega by kappa. Now beta omega dash, if one does, this comes out to be same as this part, where we have to substitute minus omega dash in alpha. Now this factor is the sole reason of getting a black body like radiation. So when you substitute beta omega dash, you get something here that won't be any change, but here you are going to get I omega dash and minus 1 plus I omega by k. So if I substitute minus I as e raised to the power minus I pi by 2 and I as e raised to the power I pi by 2, I get alpha omega dash, and take the mods, I get this point, this thing. Now if I blindly substitute here the numbers of particles created, if I blindly evaluate this term b omega dash, I'm going to get infinity using these formulas. So he goes around this problem, and actually this is up to where Thomson Banks does in their book, but he goes around this problem by creating the wave packets. And for creating wave packet, I don't understand the mathematical manipulation behind the creation of wave packet, but he just substitute this formula. He takes Fourier transform with not a Fourier transform, 2 pi n omega by epsilon p omega d omega and j epsilon to j plus 1 epsilon. Now j and n are here are integers and epsilon is very small compared to these numbers. And basically what he does by using these wave packet, he shows that at very late time around here, what actually a person observes is that the radiation the person observes is actually independent of the collapse of the star. So he does this, and this is something which neither Toms does, and I'm not sure whether Birrell's also does this. But by using this, he's able to show that why the collapse part is not important. Now, coming to the part, he also now how does he shows that a black hole radiates? So basically, he does this calculation as this. So suppose the particle, now he backtraces this particles reaching at scree plus. He backtraces them, and he says that gamma jn factor will scatter from outside the event horizon, and the remaining 1 minus gamma jn, the fraction of packets, will go inside. The gamma jn are those factor. The gamma jn are the fraction of those are the fraction of packets which are going to get scattered in such a fashion. The scattered frequency will be same as the incoming frequency, and while these 1 minus gamma jn will be the one that are going to go inside the collapsing body and then get scattered there. So he shows by taking the whole analytically continued manifold that gamma jn over e raised to the power 2 pi omega by kappa minus 1 are the fraction of packets which a black hole is going to emit. So this is this part is something which is not done which is done in Birrell's, which is done in Toms, but it's not very clear in Toms actually. But essentially one does the calculation, one stops at just by calculating this term and tells that this is the number of particles created. But what Hawkins does in addition, by going further, he talks that this is the number of fraction of particles which a black hole is going to emit. Now he goes and talks in the further section about how mass of particle, non-spherical collapse, or angular momentum, or charge of black hole is going to modify the radiation spectrum. After this, he talks about back reaction, and the back reaction part is actually quite weird for me, because here I learned something that by I was of opinion that by using a numerical method one can get a proper understanding of back reaction. But what he actually does is, by using a local observer, he proves that this black hole radiation is actually a known this black hole radiation is a known local process. So you can't just justify that we are going to send a probe at a particular point and then going to see how the particles are going to get created. So by reasoning in such a fashion, by such reasoning he is able to show that if we are of opinion that T alpha beta, which is a local quantity, the stress energy tensor at a point, if we are thinking that by using a local stress energy tensor we are going to understand the back reaction, it won't be helpful. After this, he shows that if we use the T alpha beta stress energy tensor and integrate over large space surface elements, we will be able to show that essentially some particles are flowing outside from the event horizon, or some negative energy flux is there going inside the event horizon. Yep, that's what there is in this paper. The last section is a bit of speculation of how this black hole radiation can actually explain why there is so much photons compared to baryons in our universe, and what if while doing this quasi-static approximation, when this quasi-static approximation breaks down and the black hole has a negative mass, and because of it we get a negative mass naked singularity, what will happen? Yeah, I think that's all there is in this paper.